Right, hello. Today we're going to be doing concentration. So a little recap from the last video that I went over. I was looking at relative atomic mass, I was looking at molar mass, and I was showing you the importance of N, which is going to be the number of moles. Now, within stoichiometric calculations, N is going to be the most important thing that we are going to be doing. So it's important that you understand what it represents. The next thing to do is to look at concentration. Now, concentration has a formula of C is equal to N over V, right? Where V is going to be our volume, which is going to be in decimeters to the power of 3. N is going to remain as our mole, which can be calculated with a way that you've already done, which is N is equal to M over M. And concentration over here is going to be moles per my decimeter to the negative 3. Now, some of you might be thinking, why is it to the negative 3? Because I've got moles over my dm. And we know that the dm to the power 3, when I want to write it on one line over here, I take it to the top and I change that and invert it to a negative. So it'll be moles to my dm to the negative 3. So if ever you are trying to remember how to do your concentration, it's simply in the formula that you are doing. Right, so this over here is very important because you have forgotten what dm stands for, which is going to be your decimeter, and how to convert it. Majority of the times they are going to give it to you in centimeter cubed. And your centimeter cubed to your decimeter cubed is going to be divided by 1,000. Now, to understand how to convert it, first understand how to convert it normally, just using centimeters to your decimeters, right? The reason I say how to do it normally is because it's going to apply to other physics sections later on. So over here, with my centimeters to decimeters, I'm just going to divide it by 10, because that's how you do it, from centimeters to decimeters, divide by 10. Now, what happens if I want to get it to centimeter cubed to decimeter cubed? The reason it's by 1,000 is because over here, this cubed that this centimeter has over here, with this cube this decimeter has over here, I'm going to not just divide by 10, I'm going to divide by 10 cubed. And 10 cubed is going to be the same as 1,000 over there. Right? So I'm going to quickly go over something else. Now that I've got that over there, your concentration will pretty much be dependent on your number of moles over there. So we'll look at your C is equal to your N over V again. So I'm just going to give you something else. Let's say I give you, let me pause that here. Okay, I've got the question here for you. It says here, if 3,5 grams of sodium hydroxide, I've got my E, NaOH is dissolved in 2,5 decimeter cubed of water, what is the concentration of the solution over there? Right, so I know I need to have my C, N, and V. In this question already, I've got my V, which is going to be my 2,5 decimeter cubed. I don't have C, that is what they're asking for, and I don't have N. But in the last video that we did over there, we showed you how to calculate N. And we use this formula over here. N is equal to M over M, your mass in grams over your G mole, right? Your molar mass. So it's going to be N is equal to M over M. Now, this M, like I've said, you must treat it as a constant because you can always find it on your periodic table. So I'm going to do a little side calculation here for you for my NaOH. Right, my Na is going to be 23 plus my oxygen, which is 16, plus my hydrogen, which is going to be 1, which is going to give you a value of 40. Right? Yeah, 40. Right, so I've got 40 G mole over here. Right, this 40, you're going to substitute it into this over here. I've already been given a mass for my sodium hydroxide. So there, I'm going to put N is equal to 3,5, that is my grams. So it's going to be 3,5. That is going to be over my 40, which is this one over here, because I've got that over there. A little thing that you should always be doing is putting in your SI units so that you don't forget what each of them represents. Now, our number of moles is going to come out as 0,0875 moles over here. Now, I haven't rounded off this number because if I round off this number, this would be 0,09. And it's going to give me a bigger number than what it's supposed to be. Right, now that I've got this over here, I've got my values for my N and I've got my value for my V, which means I can attack this formula again. So using that formula, I'm going to try it out again. So I'm going to say C is equal to N over V. Therefore, C is equal to 0,0875. That is going to be over my volume, which is in my question of 2,5. Always make sure that this is mole. Yes, it is in mole. And that this is in my decimeter cubed. Yes, it is in my decimeter cubed. If it is not in your decimeter cubed, you have to convert it into this. Otherwise, your answer is going to be wrong. Okay, therefore your answer should be over here. C is equal to 0,035 moles per decimeter to the -3. Right, that's just one of the examples that you can do. There's a lot more where this is going to be different. Try them by yourselves. Right, thank you very much.